Let's say we have a function that looks like this. I'll draw multiple pictures. This point is known as what? That's your maximum. That's the largest value in the entire graph. You're going to see me later talk about absolute maximum, relative maximum. Absolute means in the entire graph. Local or relative within an area. For example, in this neighborhood, in this area, that's a maximum value. That's a relative max or a local max. But when I say maximum for the entire graph, that's the largest y value. This point somewhere here is the minimum value. Now, if I change the graph just a hair, and I take the same picture, the same graph, but instead of a closed circle, I have an open circle on both ends of it. Is this a maximum? No. Not a max. We don't know what the maximum value. We don't know what that number is because you can't reach it. So we do not have a maximum value. Do we have a minimum value? Right here. That's still the minimum. I could have changed the problem just a little bit more, the same one. Now the bottom is a hole. This is what? This is now maximum. What about this one? Not a minimum. It's not a minimum value. As I said earlier, sometimes you'll hear me talking about relative or local min and local max, which means in the neighborhood, is this value a maximum value or a minimum value? So let's talk about that. Let's say I have a picture that looks like this. And I have a graph that looks like this. This point is known as what? Relative maximum. Why?
There is no maximum?
In the neighborhood, well, if the graph keeps going to infinity, even if there is one, but in, like, where's my highlighter? Do I have one here? If I pick an area around this, just a little section around it, like, I don't know if you can see this color now. If I pick this, isn't that the largest y value in that neighborhood? So that's why it's called relative maximum. Some books will call it local instead of relative. I mix and match, you know. And in this neighborhood, this is what? Relative min. Or instead of relative, again, we can call local min. In this neighborhood, that is the smallest y value that you see there. If this function continues to go up and down, we do not have what we call an absolute min, absolute max. Absolute means the largest y value, and absolute min, the smallest y value of the entire graph. Now these numbers here, where you have the min and the max, these values have a name, are known as the critical values, or critical numbers. That's a critical number. And this value here, the x value where you have the absolute min, absolute max, also known as the critical value. So, critical number. So mathematically, if I ask you to find the critical numbers, it might be more than one. Look at the picture. Number or numbers, if there's more than one. How would you find them? How would you find them? Think about the derivative. What's the definition of derivative? Derivative is the slope of what? Tangent line. If I draw a tangent line at these points, what is the tangent line going to look like? Isn't that the tangent line here? Isn't that a tangent line? And what's the slope of these lines?
0.
That's where the derivative is equal to 0. Because the derivative is the slope of the tangent line. So if you want to know where you're going to have the peak value or the maximum or the min, take the derivative, set it equal to 0. If you're going to have anything, it's going to be right there. That's your min and max. Is it always that case? Is it always where the derivative is 0? Not really. Why? Because you might have this picture. We'll do examples in a minute there. What about if you have a graph that looks like this, absolute value? Isn't this a minimum value now? That's a min. I know that's a min. I know that's a max. Or you might have something that looks like this, a V shape again. Doesn't have to be on the y-axis, but I drew them both on the y. I could raise them higher. Let me raise it higher. I don't want you to think it's always down here. I'll do a third one. Or it could look like this. These points here, this one and this one, are what? Maximum values. Is the derivative 0 here? Is the derivative 0? Is the derivative 0? By the way, what's the derivative here?
0.
Try again.
Undefined.
Undefined. Because the derivative is the slope of the tangent line. From the left side is negative. So this is actually, in this case, if you take the derivative, does not exist there. And so there's two places or two things, two conditions to find the derivative. It's if you're going to find min or max value, they're going to be located where the derivative is 0 or where the derivative does not exist. A V shape in calculus is not something we want to see because the derivative does not exist. So we don't want to see it, but sometimes you can't help it. That's what you have. Because one side of the graph might be a parabola, like this one. You might have a piecewise graph where one side looks like a parabola, and the other side, let's say it looks like this, part of the parabola, and the other side is a straight line. You can have a problem like this. F of x equals 6x plus 7 for x less than 2, whatever, you know. I can say f of x equals x squared plus 4 for x is greater than or equal to negative 1. And x plus 6 for x less than or negative 1. So when you look at that, this portion of the graph is x squared plus 4. It's part of the parabola. It's good from the minus 1 all the way to infinity. This section is a straight line, has a slope of 1, y-intercept of 6, and it will look like this. And they meet right here. So in this neighborhood, this is a relative max. Notice in this neighborhood right here, that is the largest y value. Right there. My derivative does not exist there at that point, at minus 1. The derivative f prime at minus 1 does not exist. If you look at it from this side, you go, oh, the derivative is what? 1. Because the derivative is a slope. The slope of this is 1. If you look at it from the right side, that's 2x. If x is a minus 1, that's a negative 2. So negative 2 from this end plus 1 from that end. You don't have a derivative at 0. I mean a minus 1. So the critical numbers are located where the derivative is 0 or the derivative is undefined. Critical numbers, you'll see me when I start doing that. At f prime of x equals to 0 or f prime of x is undefined, does not exist. Okay, how do we find the min maximum value? How do we find where the minimum value is, where the maximum without graphing it? So let me take an example. Find the extremes, that means min and max. And my function f of x equals 3x to the 4th minus 4x to the 3rd. And I want you to test it from x goes from minus 1 to 2. It has to be a closed interval, because if it's open, remember, If these are not included, like this open interval, there is no maximum. So I use the closed one because they could be. So if you're going to have a maximum value, it's going to be either the end points or somewhere in between. So how do we find out where's the minimum, where's the maximum? Well, step number one, if you want to find them, evaluate f of x at the endpoint. That's the first one. Meaning what? Find the value of f of -1. When x is -1, what do we have? That's a 3. And that becomes a -1 times a -4 plus 4. Isn't that a 7? And what is f of 2?
You just plug the -1 into x, right?
Correct. When x is 2, plug it in here. What's 2 to the 4? 16. 16 times 3 is what? Is that 48? 3 times 16? 48 minus, when x is 2, 2 to the third power is 8. 8 times 4 is 32. What's 48 minus 32? 16. That's the first step. Next, find the derivative. What's the derivative of this? 3 times 4? 12x cubed minus what? Is it 12x squared? Remember what I said a few minutes ago. If you're going to have a min or a max, it's probably where the derivative is 0. Remember that? So let's set the derivative equal to 0 and solve it for x. This will never be undefined. So I don't have to worry about the undefined. So set f prime of x equals to 0. You can factor out what? 12x squared. What's left? X minus 1. X will have to be 0. X will have to be what? 1. These are my critical values, critical numbers. So find f prime of x. Why are you doing that? To find the critical numbers. That's why we did that. And step number 3, find the value of the function at 0. Notice the 0 between minus 1 and 2. I can use it. And the 1 is also between minus 1 and 2. I can use it. The value of the function. When x is 0, plug it in. What do you have?
0.
You have 0 minus 0, which is 0. When x is 1, what do you have? 3 minus 4, which is a negative 1. Now, I hate to write over this and smudge it there, but out of these 4 values, can you see the 4 numbers? Which one is the biggest number? 16, right? That's your absolute max. That's your maximum value. It's actually the absolute maximum. That's the biggest value. Which one the smallest number? -1, that's your minimum value. So the minimum value at 1, it happens at 1, and the value of that is -1. The maximum value is at when x is 2 and the y value is what? 16. I don't know what the graph looks like, but I don't have to graph it to find the min and max. You test the endpoints and you find out where the function, where the derivative is 0 or undefined, and you test those points. One of them is going to be the maximum, one is going to be the minimum. Now, if you did graph this function, by the way, if you did graph it, this is what the graph will look like. We started from -1 and we went to 2, right? It's going to look like this. Something like this. I got to push the 2 out just a hair. Where was your minimum value? At 1, was it? At x equals to 1? So this is the 1 and -1, and this is the 2 and the 16. The graph will look something like this. This is your maximum value, and this is your minimum, if you graphed it. Here is my calculator just to show you that's really the graph.
And the other 2 points, would they be local maximum?
Well, this would be a local max. This will be a local max and absolute max, both. This is a local min and absolute min, you know. But when they say find the maximum minimum, they're looking for just the absolute max and absolute min. When they say find the extrema, that's what we're looking for.
The other minimum, though, would that be?
Where's the other minimum?
The other number that we got, the other 0, at 0, 0.
It wouldn't be actually neither in this case.
It would be neither?
Because if you look at it, the graph just keeps going through it, right?
Yeah.
No, notice where the derivative is 0, it's not, you're always going to have that. Those we call possible min-max. So maybe I really should write that. So your possible min-max it's where the derivative is 0 or where the derivative is undefined or what? The endpoints. Possible. Just because the derivative is 0 does not mean you have a min or a max. You see that with the 0. The derivative there is 0. At 0. But it's not a min nor a max. When we get to the second derivative, that point has a name. If you look at that picture, it's called inflection point. Why? Because it changes concavity. Notice it was concave downward, like opening upward. It's going to open downward after that. So continue to decrease, but it changes the direction which way it's open. That's called a change of concavity or inflection point. But it's possible min-max where the derivative is 0, where the derivative is undefined. It's not a guaranteed. But if they're going to be there, they'll be right there. There might not be any of them. You might have a function always increasing. For example, y equals x to the third. X cubed. If you look at y equals x cubed, has no min or max. Now, if I give you an interval to look at, yes, they will be. But y equals x cubed, it looks like this. So if I said, I want you to study that graph from -2 to 1. Now, -2, right here, to 1, which is right here. Let me erase the rest of it. Now I have a min-max. But if I don't give you that interval there, then there is no min or max, because it keeps rising. What's my derivative? It's 3x squared. So take that derivative, set it equal to 0. X will have to be 0. There's 3 test points I have to test, where the derivative is 0 and where the endpoints. So what's f of 0? What's f of -2? -8. And what's f of 1? Isn't this your minimum? And this is your what? Maximum. And you can see from the picture, that's my minimum. -2, -8, obviously that's not to scale. And my maximum 1 and 1. You're always going to find the min and max either where the derivative is 0 or the derivative undefined or the endpoints. One more example with these. Let's give you something where the derivative might be undefined. Let's see. G sub x, I get tired of using f of x. One over x minus 2. And I want you to study that from 0 to 1. Find the extremes. Notice I can take the derivative using the quotient rule, right? I'll never do it that way. Too much work. Because if I change that, this is what? X minus 2 to what power? -1. Use the general power rule. What's the derivative? Move the power to the front. X minus 2 to what power? Subtract 1 from that. -2 times the derivative, what's on the inside? Which is 1. So when you clean it, that's -1 over x minus 2 squared. Where is my derivative equal to 0, or g sub x? When is that fraction going to equal to 0? Never equals 0. Why? When you have a fraction, for the fraction to equal to 0, that means the top will have to be 0. When is -1 going to be 0? That will never happen. You might say, well, when x approaches infinity. I go, good, let me know when you reach infinity. Then I'll plug it in. Keep walking until you get to infinity. I'll plug it in when you get there. So there's no here, no solution to this one. When is the derivative undefined? Again, for the derivative to be undefined, that means what? In this case, the fraction, the bottom has to be 0, because you can't divide by 0. So when x minus 2 squared equals to 0, and that means what? X will have to be what? 2. Here's the good news. The 2 is outside my limits. My interval from 0 to 1. I can't use the 2. So I don't even have to test it today. This is outside the range. The range has to be from 0 to 1. They tell me only study this from 0 to 1. This number is 2. I don't care about it now. So I only have 2 values to test, the 0 and the 1. What is g sub 0? Negative 1/2. And what's g sub 1? Negative 1. This is your maximum. At 0, comma, negative 1/2. That's a comma. And this is your minimum. At 1, comma, negative 1. I bet you if we put the window on my calculator 0 to 1, x from 0 to 1, before I do anything, x is 0, minimum value. The largest value is 1. And I'll put the y value negative 1 to 1. Let's see if that will do it. And I want to graph 1 divided by parentheses x minus 2 close parentheses. There we go, graph it. I set my window from 0, x is actually 0 to 1, and this is what I got. At 0, let me just see my window. From 0 to 1, one over x minus 2. Maximum value doesn't make any sense, the picture here. 1 over x minus 2. Oh, you know what? One over x minus 2. That's not the y-axis. Can't be the y-axis. X min, x max, minus 2, minus 2. That should be y equals to 2. That's the horizontal, the vertical asymptote. Something, I didn't type something right, because it's giving me a 0 here. Wonder if that's the wrong minus sign. Ah, that's what it was. It's the wrong minus sign because it wasn't making any sense. It was showing the vertical asymptote as 0. It can't be. It has to be at 2. Here we go. Now that makes sense. You're going from 0 to 1. That's your maximum. This is your minimum. When I typed, I did x minus. I used that little minus on the bottom. So the machine didn't even pay attention. I kept graphing 1 over x. And it was putting that line up and down. I know I have a vertical asymptote at x equals to 2. So I knew something wasn't right. I just didn't know what it was. Like, what am I looking at? Because when I typed it, by mistake here, I hit that minus sign on the bottom, the negative instead of subtractions. And once I did that, that's not the same problem. Look how it graphs it. It shows you at x equals 0, you have vertical asymptote. I wonder if it graphed. I'm assuming it did graph 1 over x squared. Well, even that will not be 1 over x squared. X to the minus 2. I don't know what it graphed actually. What that minus sign did. Because if that was 1 over x squared, this part will be positive. It will look like this. And I kept looking like something is not right. Something is not right. That's the minus subtractions. Graph it. Now it changes the whole thing. And that's your max. You're only looking at it from 0. If you look at it from 0 to 1, that's where the problem was. From 0 to 1, you want to look at it. Oh. And you can see that's the maximum value and that's the minimum value. So that's why you need to know the stuff. Sometimes the calculator gives you stuff like, it doesn't make any sense. Something is not right.